So to explain to you even and odd nth roots and radicals, the square root has a hidden 2 up front, and written in rational exponent form, we put the 2 in the bottom. Now we know that the square root can only get real answers when the number inside is positive. So if I gave you this problem, and although these are slightly different, they do have the same answer. So we're asking ourselves here, is it possible to take the square root of a number and get 4? Sure it is. In the same way here, I can have x equals 16 again, and the square root of 16 would be 4. If I change that 4 into a negative 4, can we take the square root of a number and equal negative 4? We know that's not possible. I know the square root of 16 is not negative 4, and you can't take the square root of a negative 16. Notice that 2 is even. Now to look at the cube root here. So do we know a number that I can take the cube root of? These are 2 different ways to look at it, both the radical form and rational exponent form, and I get 3. So what this means is what number times itself 3 times equals 3? And the answer happens to be 3. The answer happens to be 27. So if I taking the cube root of 27 equals 3, because that means what times itself 3 times is 27. The answer is 3. Now what if we take that 27 and we make it negative? Okay, again, notice that the nth root here is odd. And is it possible to get an answer? Because when the nth root was even, we know it's not possible. When the nth root is odd, I can get an answer. So what times itself 3 times equals negative 27? Again, these are the same expressions written different ways. And I can see that if I take negative 3 times itself 3 times, I end up with negative 27. So the answer to this expression, when evaluated, would be negative 3. The point of this explanation is when the nth roots are even, there's only one answer, one true answer. But when the nth roots are odd, it's possible to have either a positive answer or it's possible to have a negative answer. So when you have nth roots that are odd, you don't have to check for extraneous solutions. But when the nth roots are even, you must always check.